Hi, so in this video, I'm going to show how to solve a problem on sequencing model in operational research in the category of n jobs are loaded on 3 machines. Okay, so there are 3 operations to be carried out on n number of jobs. Okay, I'm going to read out the question. A machine operator has to perform 3 operations, namely turning, milling, and drilling on a number of different jobs. The time required to perform these operations in minutes for each operation for each job is given in the table. Find the optimal sequence which minimizes the time required to carry out all the process on all the jobs. Okay, so this problem lays under the category of n number of jobs on 3 number of machines. Okay, so these jobs, sorry, the processing operations are turning, milling, and drilling. So the number of jobs are 6. Okay, so in this table, the operation time for each job is given. So we are going to solve this problem, so based on the Johnson-Bellman model or Johnson-Bellman method. Okay, so this is the 3 machine problem or 3 operation problem. So first we have to convert this 3 machine problem into 2 machine problem. Okay, so it's a simple one. So now I'm going to convert these 3 machine operations into 2 machine operations, 2 imaginary machine operations. So I'm going to consider 2 hypothetical machines G and H. Okay, so now make a table like this. Okay, so this is job as usual. This is 1 to 6. And the 3 operation is converted into 2 machine operation. So it's imaginary one. For our assumption, for our calculation purpose, I'm going to assume G and H. G and H. Okay, right. So G means, so we have to add the uh, so for my convenient, so I'm going to assume that the turning operation will be A. So I'm going to assume that the turning operation will be A and milling operation will be B and the drilling operation will be C. Okay, so G equal to A plus B and H equal to B plus C. So a simple arithmetic operation. So for each job I'm going to add A and B and C. Okay, so for G add 3 plus 8, so this becomes 11. And for second job A plus B equal to 18. For third job A plus B equal to 9. For fourth job 8. For fifth job 12. For sixth job this is 12. Similarly, so H equal to B plus C, so add 8 plus 13 for job 1. So 8 plus 13 will be 21 and 6 plus 14 will be 20 and 13 and 18 and 11 and 14. Okay, so this is how we have to convert this 3 machine problem into 2 machine problem. Okay, so then we have to check a small condition, that is um, a minimum sh should be greater than or equal to, okay, so a minimum should be greater than or equal to b maximum. So b max. Similarly, um, C similarly C minimum must be greater than or equal to B max. In some problems both the conditions will be satisfied, or in some problem any one of the condition is satisfied. So at least one of the conditions should be satisfied for proceeding the further steps. Okay, so in this problem A minimum look at the table, the A minimum will be 2 and B maximum will be 8. Okay, so this condition is not satisfied. Okay, so this condition is not satisfied. Okay, next come to the second condition. C minimum should be greater than or equal to B maximum. So C minimum will be 8. C minimum will be 8. B maximum will be 8. So 8 equal to 8. So in this case both the values are equal. So this condition is satisfied. So we can proceed the problem further. Okay. Now we have to find out the optimal sequence. So to find out the optimal sequence, so make a box like 6 box, because we have 6 number of jobs. So from left to right, so as we did in the n machine or 2 job problem, we have to proceed like from left to right. We are going to fill with the G machine, so G operation or G machine. From right to left it will be H machine. So, okay, so first start from G machine. So uh, choose the minimum or smallest element in the G machine, so that is 8. So 8 lays under fourth job. So first assign fourth job. Okay, so next come to this H machine. So alternatively we have to do for H machine, the minimum value will be 11. So for fifth job, so this is the H machine. We have to fill from right to left, so fifth over. And so we have assigned 4 and 5. So 4 is over, similarly 5 is also over. So for our convenient I am going to cancel these two columns. Okay, these two timings. Okay, so next we are going to select from G. So we have 11, 18, 9 and 12. So among these 4 values, the 9 is the smallest value. And for job 3, so put 3 here and cancel that column. Next, so we are looking H machine. So we have 21, 20, 14. So among these values 14 is the smallest value, so put 6 here and strike out this sixth column, cancel the sixth column. Then we have 1 and 2. So start from the G job. G, the minimum value will be 11. So for job 1, so strike out this one, put 1 here, and finally we have 2 only. So this is the optimal sequence. Okay, so this is how we have to fill the find out the optimal sequence to carry out the process. Then so we have to find out the total elapsing time or total processing time. So make a table like this. Okay, so based on the optimal sequence, first fill 4. Okay, for the job only first going to be machine. So the in time for turning operation of fourth job is 0. That is the starting time. The out time will be, so from this table, for turning of fourth job, it takes 2 minutes time. So processing time will be 0. Sorry, processing time will be 2. So um, the fourth job turning operation will be completed after 2 minutes, or it takes 2 minutes to complete the turning operation. Then the milling, the job is loaded into the milling machine or milling operation. So until the milling, until that the milling machine should be in ideal condition. Okay, so this case the milling machine should be wait up to 2 minutes, but turning machine there is no ideal time. Okay, so after 2 minutes only, so the job can be, the fourth job can be loaded into the milling machine. So the milling operation of the fourth job will be 6 minutes, so it takes 6 minutes. So as a overall processing time of turning and milling, so after 8 minutes only the milling operation will be completed for job 4. Okay, so after that only this job will be loaded into the drilling machine for drilling operation. So the drilling machine has to wait up to 8 minutes to receive the first job. First job means to receive the fourth job. Okay, so the ideal time of drilling machine will be 8 minutes. So after 8 minutes only the job will be loaded into the drilling machine. So for fourth job, the processing time for drilling will be 12. So 12 plus 8 will be 20. Okay, so the job is not in ideal condition in between these stations, or in between these three operations. Okay, so next, based on the sequence, so next job will be 3. So third job, the turning operation takes 5 minutes of time. So first job turning operation will be completed after 22 minutes. After 2 minutes only, the third job can be loaded into the turning machine. Okay, so the in time will be 2 second minute, 2 minutes we can say, and the processing time will be 5 minutes. So after 7th minute, the the turning operation will be completed on third job. Okay, right. And see here, uh, for fourth job the milling operation will be completed uh, at 8th minute. Okay, okay, so for fourth job the milling operation will be completed at 8th minute. So the milling operation of the milling operation for the third job can be started at 8th minute. So the job should be in ideal condition for 1 minute. Okay, so after 8 minutes only the third job can be loaded into the milling machine. For milling operation of third job is 4 minutes. So 4 plus 8, so 12. So after 12 minutes the milling operation for third job will be completed. So look at here, um, the drilling operation for the fourth job is up to 20 minutes, but here the job is ready for drilling, the third job is ready for drilling, but the the drilling operation is going for the fourth job. So the job has to wait for again 8 minutes. So the job ideal time 1 plus 8, 8 equal to 9 minutes. So after 20th minute only third job can be loaded into the drilling operation. So the drilling operation takes 9 minutes of time to process. So after 29th minute the third job drilling operation will be completed. So here, so there is no um, ideal time for machine. So all the machines are in operating condition. Okay, so based on the sequence the next job will be 1. Okay, so the first job the turning operation will be 3 minutes. So after 7 minutes only we have to load the third job. So this is 10 because the processing time will be 3. So here in the previous case the milling operation will be going on up to 12 minutes. So the job has to wait for 2 minutes. So after 12 minutes only the first job can be loaded into the milling machine. So for milling operation it takes 8 minutes of time. So 12 plus 8 will be 20. And here the drilling operation in previous case will be going on up to 29 minutes. So the job has to wait for another 9 minutes. So plus 9, so will be 11. So the processing time for drilling of a first job will be 13 minutes. So 29 plus 13, this is 42. Okay, so no machine will be in ideal condition. and based on the sequence the next job will be 2. So put like 10 here. So always the out time of the turning machine will be the in time of the turning operation of the next job. Okay, so simply we can copy from here. So 10, the processing time of second job turning will be 12. So 12 plus 10, 22. So here look at here. So the previous operation the milling out time will be 20, but in this operation the turning time will be turning out time will be 22. Okay, so now the job should be the job is getting advanced. Okay, so the milling machine has to wait for 2 minutes to receive the second job for milling operation. So in this case the milling machine has to wait for 2 minutes. Okay, so the job can be loaded after 22 minutes on milling machine. So for milling operation of the second job it takes 6 minutes. So totally 28 minutes. So the second job will be come out from the milling machine after 28 minutes. Okay, so here the drilling operation is going on up to 42 minutes, but here the second job is ready for the drilling operation. So the job can be loaded only after 14 minutes. After 42 minutes only the job can be loaded. So the job has to wait up to 14 minutes, up to 14 minutes. So put 42 here, and the processing time of second machine will be 14. So 14 plus 42, this is 56. Okay, so there is no ideal machine time for turning and drilling. Then next job will be 6. So copy 22 from here. uh, so sixth job the turning operation takes 11 minutes of time, so this will be 33. So here the milling machine is completed its operation, I mean fourth operation at 28 minutes. So but here the job is ready only at 33 minutes. So the milling machine has to wait for 5 minutes. Okay, so the job can be loaded after 33 minutes. Then the processing time for sixth job will be 1 minute. So this is ready at 34th minute. Okay, but here the in drilling operation of a previous case the drilling operation is ongoing up to 56th minute. So it can be loaded after 56th minute. So in this case the job should be in ideal condition. So 56 minus 34, it will be 22. So the processing time of sixth one is 13. So 56 plus 13, uh, 69. Okay, so the machine is not in ideal condition. For first next operation based on the sequence will be 5. Next job, fifth job. So for fifth job the turning operation takes 9 minutes of time. So 33 here, 33 plus 9, this becomes 42. Here the job is ready, I mean the milling operation is completed at the 34th minute, but here the job is only ready at the 42nd minute. So the job has to, I mean the milling machine has to wait up to 8 minutes. So should be in ideal condition. So after 42nd second minute the job can be loaded into the milling machine. So 42 the processing time, this is the fifth job, processing time will be 3. So 42 plus 3, 45. 45. But here the drilling machine was ongoing up to 69 minutes, but here the job is ready at 45th minute. So subtract 69 minus 45. So that is the job ideal condition, the job ideal time. 69 minus 45, this will be 24. And at 69th minute only the job can be loaded into drilling machine. So the processing time will be 8 minutes. So 69 plus 8, 77. Okay, so the machine is not in ideal condition. Okay, that's all. Now so we have to find out the total elapsed time. Total elapsed time equal to, so this is the total elapsed time to complete this cycle. So so we have to assume it as a cycle. So the cycle starts from fourth job and completed at this fifth job. So the cycles in some other words I can say that the cycle starts the turning operation of fourth job and ends with the drilling operation of a fifth job. Okay, so this cycle complete will be completed at 77 minutes, or it takes 77 minutes to carry out all the operations. Okay, this is the total elapsed time. And job ideal time. So the job ideal time equal to, so add all those things, 9 20 34 34 56 56 plus 24 sorry 56 plus 24, this is 80 minutes. And machine ideal time. Machine ideal time equal to 2 plus 8 10 10, this is 10 10 10 25. So this will be 25 minutes. Okay, so this is the total time taken, job ideal time and machine ideal time for the given problem.